Hello, so this is a video recording of a workshop which we are going to present at DataFest Tbilisi. So let's get started, and those are the points which we discussed today. So quick info about me, then we will try to answer whether this 3 is hard or easy to get started. So after that we will go to practical part, and for that we will need to know about SVG essentials, and after that we will start working on actual chart. We will analyze this graph and we will try to disassemble it into different SVG elements. After that we will start checking the actual data from which this chart is built, so it's temperature data, and also we will try to calculate several metrics, for example minimum maximum values, and after that we will actually start coding. So we will code it inside online editor. Link is already here, and you can just, so yeah, first link is, you can visit this link and you will be able to see this slide, and you can click this link to open the template which I prepared for this workshop. Yeah, and after that we will know about scales and arc commands which this tree offers, and finally we will build radials and some axes. So yeah, hopefully everything will go well. Okay, let's get started. So first, as I mentioned, you can visit this link. You can just write datafest.infoec.com, and it will open all materials needed for this workshop. Okay, so about me, quick info about me. I work as senior data visualization developer at Infograde. You can find me either on Twitter, on LinkedIn, and send a connection request. Yeah, if you are interested. And okay, so let's get started. First question I wanted to ask, or I wanted to answer, is whether these 3. So first, what is this 3? Basically, mostly this 3 is used to build custom visualizations. Custom and interactive visualizations, which are hard to do using only standard charting tools. So yeah, this 3 is mostly used in this area, and so the question, is this 3 hard? Yeah, it is. But more correct question is, why is this 3 hard? And this 3 is hard because it's not it's not standard charting library. It's kind of tools. So this 3 is collection of tools which are designed to work together, and to use it, we also need to have we also need to have information about SVG. Basically we need to know about some HTML, we need to know about JavaScript, and most importantly we need to know about SVG. So yeah, in this lesson in this workshop we will try to learn about SVG essentials which are necessary for this workshop, and I tried simplifying this process. So we only learn about what we need to build this graph, and yeah, if you want to know more, Yeah, there are many resources and you can just go and find it. Okay, so let's get started. Let's open this notebook and let's see what is SVG. So let's start with SVG basics. So basically SVG is a vector. SVG is HTML element. It's one of the tag like span or div, and SVG is one of the HTML tags, and it is vector element. What I mean by vector? Um, so basically, when you zoom in, it won't change the quality, so you won't see pixelated results like in the image. Okay, so simplest possible example of SVG is this. So we are just writing SVG. Yeah, by the way, this is observable notebook, and observable is very good place to experiment and yeah, experiment with your ideas and yeah, do some things. And for example, in this case, we are going to showcase SVG code under this notebook, and we can create cells. It can be either HTML or SVG or Markdown. In this case, we are going to use HTML cells, which means when we are writing code, it will recognize it as an HTML. Okay, let's start, and we can write SVG, and we can click this triangle icon for running it, and that's it. So we are getting SVG here, but it's not visible because it needs some additional styling to make it visible. Okay, let's start with background color. Let's add it, background color aqua. Yeah, so we got our SVG, and let's make it prettier, so we can add width is 300 and height equals 300. Yeah, and now let's add border radius to make it round. Yeah, that's it, and basically this is SVG, and we can add additional SVG elements under this code, and we will learn about them. In our case, we need to know about circle, we need to know about line, which is here, we need to know about text, and we need to know about path, and also we need to know about G element. Okay, let's start from circle, and basically circle has most important property is probably radius, which is called air, attribute property, and so it determines how, I mean, what will be the radius of the circle. So we could maybe it will be there if I start from beginning. We can write like this, and as I said, most important, so if we run this cell, we won't see anything, but if we add radius attribute, we will be able to see circle here. So by default it goes at 0 0, so coordinate system goes from here to here. This is x and this is y, and this is 0. So by default all of the SVG elements start in 0. So we can then, yeah, we can make it bigger, yeah, and then we can move this circle in the center, and to use, I mean, to move it to the center, we can use transform translate property. So syntax is like this: transform equals translate, and we are passing x and y. So x will be, in our case, 150, and y will be 150 as well. Yeah, so there is a shortcut, shift and enter in my keyboard, which basically runs this cell, and I am accustomed to it. And so you can also click this run cell button to run this code. Okay, so we learn about transform translate property, and we learn about radius property. Okay, we also can color this circle, and for that we can use fill command. We can just color it as red, fill equals red, and we can also have a stroke or border. It is called stroke, and it will also receive color as an argument, and we can just have black stroke. We could so if we just want the circle and not the fill, we can just specify none inside fill, and we will just have this black circle with empty space inside. So basically this is how we can build the circle inside SVG. And as I mentioned, when you zoom in, it won't lose any quality, so it will stay and it won't get pixelated. Usual normal image would get pixelated. So next part is, it's better to pin this cell. So next part is about line. Apart from circle, we can also build a line in SVG, and so to build the line, basically we need two coordinates: start coordinate of the line and end coordinate of the line. And as I mentioned, this is the 0 point axis, and this is x, and this is y. And let's create a line which will go from 0, 0 to half of this SVG. And so in that case, line has following attributes: x1, y1, x2, and y2. So x1, y1, x2, y2. And syntax is like this: line, and we can specify these properties inside line. X1 in our case will be 0 because it starts from here. Y1, so by the way, if I run this HTML now, nothing will be visible here. So y1 will be again 0, x2 will be half of SVG size, which is 150, and y2 will be again 0. Okay, so we run it, but nothing is visible. It's because by default line doesn't have any fill. So in this case, if we omit this fill property, you can see by default it's black. But if we omit this fill property here, so basically nothing will be displayed. And to fix this, we need to specify stroke. And that's it. Now stroke is visible and line is visible as well. And so we can also have this transform translate property applied to line, and transform also has other properties. So other than translate, it also has rotation properties. So if I wanted to rotate this line from here to here, I could just specify transform rotate property like this. Transform equals rotate, and it will receive degrees. So for example, 1 degree, 2 degree, 45 degrees, and 90 degrees. Yeah, as you can see, transform rotation works like this, and so it will rotate around center property. Okay, now so this is about lines. Okay, now let's learn about text. Text is possibly it's the easiest possibly. So it's just text, and we can write anything inside it. Text, and as it was the case for circle and line, it also starts from 0 0. So actually 0 0 is here, and texts are added here, and it's not visible because it's partially visible if you can see it, but by default texts are above the line, so that's why we can see it. But we can move those texts down. We can just use transform again, transform translate, and we can specify x and y. So we can go to 150 for x and 150 for y. Yeah, and it will move in center. So center point is here. Actually, center point will be here, like here, and as you can see, text is a bit above it and bit right side of it. So we can also center the text around the point, but I think we don't need to use it in our visualization, so I don't mention how we can do it. Okay, so this was the text. So again, it's just text property. Using transform, we are moving this text around, and we can just specify what text we want inside those tags. Okay, and probably most complex one is the path element. Path element is a custom element, and we can specify the shape, how we can specify the path for it. So syntax is like this: path, and it has one attribute called the, and we have to specify a command string for this d. And so again, this is most complex part of the path element. But command is, so we don't need to know about it much, so we just need to know that it receives some commands which it uses to draw something on the screen. So for example, the command is like this. First command is move, or move to 0 and 0, and it will start drawing a shape from 0 0 point. Then we can specify line to 150. So this means it will go here, and then we can go again 0 and 300. So basically what we did, first we came here, then we moved here in the center, and then we moved here. So if I run this code, you can see basically shape is drawn. And so as it was the case for the circle, this one also has fill property and stroke property. So if I want to write, for example, stroke equals black and fill equals none, we will have this result. If we want this line to move to original point, we can just specify, okay, let's do like this. Now we can just specify set in the end, and you can see we have the line connecting to the original point. And by default we can't see it, so by default if this line is outside SVG we can't see it, because by default overflow is hidden, but we can specify overflow visible in the CSS and we will be able to see it. We will be able to see elements outside of SVG. So this is the simplest example of the path, and again it has fill properties and it has stroke properties. We can specify fill yellow, for example, and we would get this result. Again, most important part is this D command. Usually, so basically D3 gives us some functions which automatically generates this element, this string element, so we don't have to worry about this. But I still wanted you to know the details. And last one is the G element. G element, you can look G element as kind of wrapper for circles. And in that case, you can see we have two circles. One has radius of 40, and second one has radius of 20, and we specified center x and center y coordinates. So those circles moved here, and actually this is wrong. It would be better if I use transform translate property. Okay, let's replace this center x center y using transform. Transform equals translate 160 and 150, and let's try to run this code. You can see this circle mode, and now remove this one. So it's in place now. Let's copy this one and do the same for the second circle. So we have 260 and 150, and let's remove this one. So as you can see, now we have two circles filled with orange, and we don't need this one again. We don't need to know about stroke width, we just need to know about the stroke. And so what's the G element? G element, again, I'm assuming it stands from group, and G element basically groups other SVG elements, and then we can move G element itself, and all of its children will move with this G element. And syntax is like this: G, and we can wrap those two circles inside this G element, and we can apply transform property, transform translate. So if we want to move this G element 10 pixel right side, I can just write 10, and as you can see, both circles moved to the right side. So if I want to move it to the left side, I can just write -100, and you can see both circles moved on the left. I could also rotate it rotate 10 degree. You can see it's being rotated. Okay, so we will use this G element in our visualization as well, and we will use these rotation properties. Basically this was the basic of SVG elements which I wanted you to know, and we are gonna use those elements in our code. So next part will be disassembling this graph into different SVG elements and understanding how it is built and how we can build it. So let's use the info we got in SVG Essentials part, and let's try to disassemble this graph into different SVG elements, which will help us later when we actually start building the graph. Okay, so I have this graph opened in the new screen, and we can take a look at it here. So what do we have here? Okay, so we have some texts. For example, this is SVG text. We also have several texts, bonus names. We also have texts for axes, and we have white background, but yeah, we will say how we can do the same background. Okay, so we also have radial axes like this, those, and we have vertical axes. And most importantly, we also have those bars, which are dependent based on the data. Okay, so in this case, text is SVG text. Those are lines. Those vertical axes are lines, basically SVG line elements, and those radial axes are actually circles. So they start from this radius, and so we actually have 5 circles, 5 or 6. We actually have 6 circles with different radiuses, and their fill is set to none, but stroke is set to something, probably gray or black, I don't know. Okay, and again, each of these bar is actually a pass, and so yeah, and this tree has built-in functionality which will help us to build the path like this. So we will actually build each path independently, and then basically this tree will take care of this. Most important part is to pass relevant data to the function, and this tree will be able to generate this the command for this kind of elements. Okay, so basically this is what I wanted to say. Again, we have circles for radial axes, we have lines for vertical axes, we have some texts for month names and axes, and also we have one label here, and most importantly we have path shapes, and which are based on the data. Okay, let's continue and let's take a look at our data. And for that we actually need to click on this one. As I mentioned, I already created a template for us to begin with. It's an online it's online and Visual Studio Code like environment, so you can easily get started right away. You don't need to install anything. And basically we need only two files. One is data.json and one is index.js, where we will be working. But first, let's take a look at data. So data is just an array of objects which has temperature in Celsius and it has date. And date starts from August 1, 2021. And so we have information about temperature starting from August 2021, ending with July 2022. And as you can see, we only have two properties. One is temperature and one is date. So yeah, fairly simple data set. And let's see. So in this case, each bar and each bar color represents each row from this dataset. As you can see, those temperatures are higher in August and September, and it is getting lower in winter basically. And we can see it here as well. Okay, so this is our data, and we also need to know about the functions which we will be using from these three. Those are these three min and these three max. And to understand how they work, we can just go in SVG Essentials part. We can add another section here. Let's call it data. These three min and these three max. Okay. So we won't need to do this. This will be already here once you will visit this link, and I will just specify data here. Okay, let's call it data temp, and as you can see, data temp is array of 365 elements. And so what I wanted to show you is usage of these three min and these three max. Basically they return minimum and maximum based on the past data. So for example, in our case, we need to find minimal temperature from the data and maximal temperature from the data. And for that, we can just specify data and which property we want minimum of. So in this case, we want minimum temp, so it will be d.temp. Then we need to pass data temp, and in this case again data temp, and we need to pass d.temp. Okay, so minimum temperature is -8 and maximum is 21. Yeah, so basically this is how this function works. We can invoke it using t3.min. We can pass data, and second argument is a function which will access the property which we want to use when calculating minimum and maximum. So in that case, it will return minimum temperature from this data set and maximum temperature from this data set. Okay, so I think we almost know everything which we need to get started, and yeah, we can get started now. As I said, I already prepared this template and you can just use this template. We can go to index.js and start coding here. Okay, so let's get started. Let's click this get started link and it will open our template, and let's quickly review what's written here. So first we are loading this free library, then we are loading the data from this data.json file. Then we are creating HTML element. Then we are invoking our chart function where we will write this, where we will write our code, and finally we are basically we are displaying result which chart returns on the page. So this part is quite simple to understand if you know about HTML and basic JavaScript. And okay, let's go here. So we are defining two initial arguments, two initial parameters. One is width and one is height, which determines our SVG width and height. Then we are actually creating SVG, and you can see the syntax T3 create SVG. Then we are specifying attributes for this SVG. So those attributes are it's SVG attributes. It's already part of the standard, and this three just gives us possibility to specify attributes like this in chaining syntax. And basically what we are doing is we are specifying width and height, and we are specifying styles, basically font family and font size, which font family and font size. And finally we are also specifying background color, just to make sure that we can actually see the result. Without this we would just have white rectangle, and we would not be able to see, and we would not be able to understand if anything is drawn here. Okay, so let's get started. And one major thing which we need to understand are scales and arcs, but we will go there. Okay, so first thing we need to make sure is that we start drawing from the center, because if you remember, we said that initially all of the elements start drawing from here, and if you want all of the elements to start drawing from here, we need to create G element, and we need to move this G element in the center. Okay, for that I can use the code like this: const G equals svg dot append G. Okay, so this actually created G element, but if we check it in inspect panel, okay, this is our SVG, and you can see this G element is in the top left, so basically where elements are going when first created. Okay, so if you want to move this G element in the center, we need to specify transform translate property. So we can do it like this: attribute transform, and second argument will be translate. So we are specifying this backtick string, so we can use this syntax. And so we need to move this G element in the center, and for that we just need to specify x, which will be width divided by 2 and height divided by 2. Okay, and if we check this, and if we expand, you can see this G element is in the center now. Yeah. Okay, so next part is, okay, let's take a look at our chart, and let's see what we need. Okay, so probably first we need to calculate minimum and maximum. So in order to create scales which will be responsible for calculating this shape, we need to calculate minimum and maximum for each, from the data, and we already did this. In here we can either copy this one, but I would prefer if we do it like this: const mean equals d3 dot mean, and we are passing data which we are receiving here, and we need the dot temp. Okay, and we can do it again for the max equals d3 max. Okay, and let's check if we got results right. Let's log the result, mean and max. Okay, let's see. Yeah, so here is the log result. Max is 21 and mean is -8, so basically the same as we got it here. Okay, so now we need to talk about scales and arcs. For that, let's go here and let's try to understand how scales work. We don't need to understand about scale time. I will just remove this one. So we need to understand how number scales and color scales work. Syntax is like this: d3 scale linear, and we need to specify domain and range for the scales. And okay, so let's try to visualize it. So suppose this, we need this one. Suppose this is our data, range of our data. In our case, for example, we had -8 and 21, and this is yet another dimension. Okay, so usually visualization involves mapping initial data into some dimension, right? So it can be color, or in this case it can be height of the bars, position of the bars, etc. And in every similar cases, usually we are using scales which maps our initial data into something, right? Into some number. So for example, in this case, we need to map our data, which is from -8 to 21. And we need to understand, for example, if I have the temperature where value is 20, I need to understand how higher should I display it inside chart, right? And for that, we can use scales. So basically, scales maps data numbers into visual numbers. Yeah, but this is wrong, so we don't need 400 here. So 0 and 400. So mapping will be done like this. So -8 will be mapped to 0, and 21 will be mapped to 400. And this means, For example, 200 will be mapped to, I don't know, it will be about 3 or 4 or 5, I don't know. So basically inner number. Okay, let's try it based on the example. In our case, we already calculated min and max. Let's call it min and let's call it max. And we can specify them inside domain min, max, and we can specify range. And what this value scale this value scale will return function which I can invoke. For example, if I pass this number, if I pass -8, this will return 0. If I pass 21, for example, it will return 200. As you can see, this scale continuously maps data values into the range values. And in this case, range values are our visual values for visual pixels which we want to map the data to. So for example, if I want to understand what will be the pixel size for the temperature with value 20, I can just invoke this value scale with 20 and it will return something like 193, right? And yeah, so if I wanted, for example, to invoke it based on 5, it would return something like 90, approximately 90. And again, as you can see, this value scale maps data values into visual values, which we need to use. Okay, and the same is true for the color scales as well, but instead of values, we are specifying colors, and it basically, I could do the same here. I could specify min and max, and invoking color scale for the same values would return colors and not the numbers as it was the case for here. Okay, I can do the same for 21 and it would still return colors. So in this case, when I am invoking this function, it returns yellow, so this color is actually yellow, this RGB color. But when I try to invoke this function using max, which in our case is 21, it returns red value. You can tell that this is red because this stands from RGB and air is red in this case, and it's maximum, and other two values are minimum, so this is red. And the powerful value of this color scale is that we can also specify something like mid value. So for example, if I wanted to understand what color should be, for example, the value with 10, temperature with 10 value, I could just specify color scale 10 and it would return corresponding color for the 10 value. Okay, so this is what I wanted to say about the color scales. And now let's understand what are arcs. So this is quite complex topic. So basically, arcs are helping us to draw radial shapes. And this arc function, syntax is like this. So we need to specify inner radius, outer radius. start angle and end angle. And so for example, suppose center is here and I wanted to draw the shape something like this. And to draw the shape like this, I need to understand inner radius from this point. I need to understand outer radius, and yeah, so those 2 points will be the same value. So I just need to understand inner radius, and I also need to understand outer radius. So from here to here or here, it's the same. And I also need to understand start angle. So by default, angle starts here, and I need to understand what's the angle, what's this angle. So this is start angle, and I also need to understand end angle, like this. And this information is enough for these three to draw shapes like this. Let me color it. Okay, let's try it based on the example. So, for example, suppose I want to draw the shape like this, and center is here. So, in that case, I need to specify inner radius will be 0, outer radius will be something, for example, 100, start angle will be 0, but end angle will be math pi divided by 2. Yeah, as you can see, this works. And in this case, so difference between, so if you remember, we mentioned about transfer, translate, rotation. In that case, we would specify angles, but in this case, we are specifying radians. And if you remember, mass and pi is 180 in angles. So yeah, so in radians, pi equals this number. So this means if you want to if you want to draw, for example, half circle, I could just specify start angle 0 and end angle mod pi. If I wanted to draw shape like this, I could just write start angle would be 0 again, and mod pi would be multiplied by 3 and divided by 2. So if I wanted to half circle again, but if I wanted to start it from here, I could just specify start angle mod pi divided by 2. Yeah, so basically this is how this arc function works. Basically this arc function generates this pass d commands which I mentioned. So you can see what's drawn here. Basically just pass, and this arc result which I am calculating here, it just goes inside the property, and it's just some string. So if you want to see inspect, you would be able to see that. So it's just some string inside, and this string is generated by arc function. Okay, so how is this relevant to our visualization? Okay, so this is relevant because we are going to use this function to draw those bars. And in this case, each angle would be each angle would be whole angle, I mean basically 360 angle divided by data count, and in this case it would be, for example, like this: math pi divided by data count, data temp count. Oops, data count. Not count, length. Okay, and this is the each angle in our case, and if we call it each angle, and for example, if we want to specify, okay, so if I want to draw a single bar, I could just do like this: 0 and each angle. And you can see something is drawn here. It's not easy to understand. Okay, let's multiply to 3, and you can see how it looks. And then if we want to draw this data for each bars, we need to, for example, to draw the second bar, we need to draw it like this, not the second, third bar. If we want to draw a fourth bar, we would need to do like this. Yeah, you can see, I don't know if you can see, something is drawn, but it's not easy to see. So if I increase outer radius, maybe it will be easier to see. Yeah, so it's not easy to see. Okay, so anyway, my point is we will need to use this function to generate arcs like this. Okay, so one thing to note is that each function can each property can receive function. So for example, I can write like this. So instead of, for example, 90, okay, let's write 0 and 90, and let's see the result. And angle would be math pi. Outer radius is 0. We need to, yeah. So suppose, yeah. So one thing to note is that when invoking this arc function, we can also pass the arguments. So for example, in this case, if I want to draw the shape like this, suppose I want to draw the shape like this, I can specify parameters here which I want to pass. So for example, I could specify start angle. Start angle would be, in this case, math pi, and end angle would be, okay, let's make it more simple, and suppose I want to draw the shape like this, and in that case end angle would be math.pi. Okay, and instead of this I could just use this passed argument, and I could make it dynamic, and this means end angle would be the d dot end angle, and start angle would be d dot start angle. Yeah, and you can see now it's written. So basically I can specify arguments instead of writing a static number here. I could just specify inner radius and outer radius as well here. Probably this is easier to understand, and I could just make it like this. Okay, and as you can see, result is the same, and now I can change this, and I can play with arguments and result will be the same. And this is very powerful because now this means that we can use each data, we can calculate inner radius, outer radius, start angle and end angle for each data, and we can just use the same arc function for calculating this pass d command. Okay, let's get started then. Okay, let's just copy and paste this arc function here. Okay, so now we have arc, mean and max, and we can actually loop over the data and we can calculate each inner radius and outer radius for our data. Okay, so now let's try and calculate each angle of each radial bars. So our radial bar will look like something like this, and now let's try and calculate what will be each angle of each bars. And for that we can just write, we can either write here or here, it doesn't matter. I will write here. So const each angle equals, so overall angle is 2 multiplied to math.pi, and we have to divide this to data lengths, and let's log it and let's see the result. So this looks like it's correct. Okay, so next part is calculating minimum radius and maximum radius, so basically inner radius and outer radius. Okay, so we start from here, and data will change between this small circle and larger circle, and we need to define what will be the inner radius of this and what will be the outer radius of this. And for that we can just have something like, for example, outer radius could be width, so basically 90% of width divided by 2. Okay, so this will, so basically this, so this will be roughly width divided to 2 and then taking 90% from it, roughly like this. Okay, and inner radius could be so we can define it like, we could say it's, for example, 30% of or 35% of half width. And okay, let's write like this, divided by 2 and multiplied by 0.3. Okay, and let's log it to make sure we got something. Looks like it's correct. So inner radius is 120, outer radius is 360. Okay, so next part is so next part would be but probably it's better if we calculate. Okay, so first let's do something like this. Let's loop over the data and let's define each property for each data. So we could define, for now we could do something like this, inner radius would be, we could do the same. We could have this inner radius assigned, and we could have outer radius assigned like this. And for the start angle and end angle, we will need E parameter. E basically is an index, so start angle would be E multiplied by each angle, and end angle would be E multiplied by each angle, basically plus 1, but we can do like this. Yeah, and let's log the data as well, and let's see what we, yeah. Okay, so we have data like this, and now you can see that we have inner radius, outer radius, start angle, and end angle assigned to each data. So now we can just use this arc function, and we can just draw those arcs. And for that, we can use following function. First, we will write like this: g.select all pass. Yeah, we can write arc. Yeah, so basically, yeah, it will be better if we write like this, arc. And then we need to bind the data, and our data, we can bind our data to it, and then we need to actually add those elements, and we can use this join function for that. And we need to add pass elements, and finally we need to specify D for the pass element, and we should return, basically we should return the result which arc function generates. So we can just write return arc. So basically we can pass the, so this arc function expects that past argument should have those properties specified, so inner radius, outer radius, start angle, and end angle, which we defined under this. And when we said that we should return arc, I mean based on each data row, so basically this draws shape which is generated using this function based on this data. So for example, we could specify something like this: math random multiplied to for example 100, and you can see how it is drawing. Maybe I should refresh it. Yeah, you can see what is drawn. Maybe we can do the same for the outer radius, and you can see now how it is drawing. Okay. Okay, so let's check our visualization now. So it is at datafestinvoice.com. Let me quickly open this to the new tab. Okay, so and let me open them side by side. And as you can see, arc is already drawn. So now we need to have, we need each arc to have different heights, and yeah, basically we need to have different heights and different positions. I mean, positions will be same, but for example, positive bars should go up above 0, and negative bars should go below 0. So this means we have to create a new scale. We have to create new linear scale, and we can calculate inner radius and outer radius based on this scale. Okay, let's copy this one and let's do like this. Maybe better approach will be, we can just check. So now we can check if d dot temp is more than 0, we can have different inner radius and outer radius attached, or otherwise we can different inner radius and outer radius attached. Okay, we can write like this. So if temperature is more than 0, this means inner radius would be somewhere here. So it would be like, I don't know exactly, so roughly let's say it would be 30 pixels, and outer radius would be the same, but if temperature is less than 0, in that case outer radius will be equal to so outer radius will equal to something. Okay, no, I'm not telling it well. Okay, so based on this example, as you can see, if bars are big, so if temperature is bigger than 0, we have bars on the top. Yeah, so our inner radius and outer radius is like this. So this is our inner radius and this is our outer radius, and we still have a circle here which is equivalent to 0 scale, and this means we have to find this number so that we can specify inner radius and outer radius differently. So instead of 30 we could have some number, and for that I think it's time to define our linear scale, our value scale, which will determine the height of each bar. Okay, we can do like this. We can write it, I think best way would be to write it here. Let's call it value scale. So value scale would be this 3 dot scale linear, and we have to pass domain and range to it. So domain would be min and max, and range would be inner radius and outer radius. Yeah. So we know that this min and max in our case is -8 and 20, and if I call it like this, so if I want to find the value which is proportional to 0, I can just write like this, value scale 0, and I will get the right number. I can do the same here. I can write value scale 0. Yeah, and as you can see, some bars where temperature is higher than 0 go above this fold, but some bars go below this fold. And now we want those heights to be proportional to the data itself. So instead of specifying outer radius, we can just specify it based on the scale. So we can just write value scale dot temp. Yeah, and now we can see above 0 we have correct height for each bars, but below 0 we still have inner radius specified and all of the bars have the same height. So we can just write again value scale dot temp, and now we have the correct shape for this visualization. Okay, yeah, nice progress. Now we want to, probably first we want to get rid of this teal color of the SVG. Where is it written? Yeah, in this case I can just comment this line and you can see we have this kind of graph. And now we want to now we want to color it accordingly, and to color it we can use the color scale, and basically it's the same, but instead of numbers in the range we are specifying colors. So we can just copy this one and paste it and call it color scale, but again instead of specifying numbers inside range we are specifying colors. Okay, let's start with other colors. Let's beat yellow and for example red. So each value will range its colors from each bar will range its colors from yellow to red based on the temperature. So to specify color of each bars we can write like this. So if you remember, it was the fill property which was responsible for coloring the shape, and we can write attribute fill, and then we can pass function, and inside this function first let's return normal color like blue. Okay, you can see we have blue colors, but as you can see there are some strokes here, and they are by default, they are not stroke, but there are some spaces between each arcs. I don't know if it's possible to see it, but I can see it. And to remove these spaces we can specify stroke and return the same color. Yeah. Okay, I still can see it. Okay, maybe I need to specify stroke width. Stroke width basically is what it says. Yeah, so interesting. Okay, so I will just remove it and we can have this function, and I think this will be enough. Okay, so instead of blue we want value dependent color, so we can just do the same. So for example we can color inside, so we can assign color in the data itself, and we can just return the problem. So we can just return the color property from here. So this is our data, and we can just write d.color, and we could do the same here, so we don't have to calculate it 2 times, and we can just specify color here. For example, now set it as yellow, and let's save it and let's see. Okay, yeah, now as you can see we have yellow colored shape. Okay, so now we want value based coloring, and for that we can use this color scale which we defined, and we can specify color like this: color scale d.temp. Okay, now you can see that our coloring is different. Now minimum value starts from yellow and it goes to red. Maximum is red. But yeah, so this is possible, but we don't want that. So we want gradation between different colors. So if it's minimum, we want gradation between blue colors, and if it's more than 0, we want gradation between yet another like reddish colors from orange to red. And for that we can make some adjustments in the color scale, and we could write like this. So we could say we have 4 color ranges from min to 0 and from 0 to max. And we could also specify 4 colors, which color we want to use, and we could write like this. So we want minus to be dark blue, and then we want it to go to sky blue. Now as you can see, min and this part works well, but for the positive temperature it's different, and we need to specify yet another we need to specify 2 colors. So first will be orange. Now it's closed, and instead of red, let's specify dark red. Now as you can see, we have the shape and colors are matching as well. Okay, so now we need to define the axes for each. Basically we need to define radial axes now, and for that we could use Tix function of the scale. So for example, if we go in our SVG Essentials notebook, we can write something like this. So for example, we have, where is our scale? As you can see, we can invoke Tix function from the value scale, and it will return well formatted colors, well formatted array for numbers. So for example, as you can see, for this scale, for minimum and maximum scale, it returns nice numbers between minimum and maximum, and we could use those nice numbers to draw several radial axes. In our case it would be circles, but as you can see, we only have 6 circles here. So 1, 2, 3, 4, 5, 6, and instead of 15 we want about roughly 6 ticks, and we could just specify ticks here, and it would return again nicely rounded numbers, and it would return 6 values in this case. So this is just a tip. For example, if I pass 7, it would still return 6 values, because you could not find another nicely rounded numbers, another 7 nicely rounded numbers. Only 6 was found, so 6 result was returned. Okay, so we can do the same. Okay, and let's write it here. Okay, let's comment. This one is radial axis, and we can, so first we need to get those numbers, and we can just write const radial axis data equals value scale dot tix. Okay, again this will return just those numbers, and we can use this as a data, and we can create 6 circles based on this data. So we can just write again the same g.select all radial axis, then again bind the data radial axis data, and then we can create circles using join method, and finally we can specify radius for each circle, and radius in this case would be so this day is basically each number, and we can specify value scale there. Yeah, you can see something is returned, but by default those circles are by default fill is set to black, and we can just specify fill none to see the result. Okay, yeah, it's hidden, but this is because we haven't specified stroke. So if we specify stroke and let's be it gray, you can see we have this kind of radial axis draw now. Okay, as you can see, it's on top of the bars, and to get rid of this we can just have black for the stroke, but we can also specify opacity and let it be 0% 1 opacity. Yeah, nice. Yeah, so as you can see, we are close. So now we just need we also need to create this axis, this number axis, and for that we can just create text elements. We can do the same here. We can just copy this one, paste it, and now we want radial axis texts. So we could write anything here. I mean, it's not anything, but so this is actually a complex topic. So what we are doing is, so when we are invoking select all and writing this selector as an argument, so first what we are doing is that we are telling this tree to find all of the elements with this class. So this is CSS selector, and then we are telling this tree that this tree should bind this data to found elements. And for example, if only 3 elements was found, but inside data we had, for example, 10 element of our array, this tree would create 7 additional elements for this missing data. But in our case, this element does not exist, so this number is 0, and this tree will create 10 additional elements when we are joining this. So basically what this means is that we are creating 10 additional, not 10, I mean 6 additional circle elements, because we have 6 data array. Okay, so instead of circle, now we want to create text, and we want to transform each of them. First, let's say b0 0, and let's see. I can't see, but let's specify 50 and 50. And we need to specify actual text value for them, and this will be basically itself. So as you can see, our numbers are here, but we need them to here. And for that I can just specify again, so I can pass the function, and I can specify 0 as x value, and I can specify value scale there as an y value. And as you can see, we have this result, but we want it to go above, and if I want this to go above, I just need to proportionally change this number, I mean y value, for each of text, and I can just write minus value scale there, and it will go above. Okay, nice, but as you can see, in this case we also have background which makes it possible to actually read this text, and in that case it's not easy to read this text because they have kind of those colors of this text and bars are close to each other and it's hard to differentiate. And so to create a background for this text, I can just attach a stroke, and I want white stroke. As you can see, it's white stroke, but now I can't see text in white background, and to make it better I can just specify stroke opacity to be 5 to make it bigger. Okay, let's see, not the opacity, stroke width to make it bigger. Yeah, now it's big, and I can just clone every number, and I can just disable stroke for each one of them. So I can just write attribute stroke equals none. Yeah, and now you can see that every number is visible. Yeah, every number is visible, and basically it's well. Yeah, we can see them well. Yeah, now it's time to create month axes, and for that we can define a new array of months. We can just write, for example, we can I already have it and I will copy and paste it, so it's just array of months, so August, September, October. And this starts from August because our data also starts from August. So finally we want to create lines for this graph, and we can just use this. Okay, let's call it vertical axis in the comment, and we want to create as many lines as it is. We want to create as many lines as we have the data under this array. So this means we want to create 12 lines, and those lines will go like this, and we also have months, and as you can see they are parallel to lines, and this means we can create G element, rotate it, and we can then add line and text elements inside it. Okay, let's get started. First we want to create G elements. Okay, let's call it const vertical axis wrappers, and this would be g.select all, and we need to create, so we call it vertical axis wrapper. And then we want to bind months data. Okay, so next we want to actually create those elements. Okay, and finally we want to rotate each G element based on the index basically. And okay, let's do it. Okay, let's do like this. First let's add a line, use append element and add the line, and this line would go from 0 0 to 0 and basically maximum value. Okay, let's write like this: attribute x1, this would be 0, and y1 would also be 0. Okay, and x, so yeah, this is x1 and 0, 1, and this is x2 and 0, 2. So x2 still would be the 0, but y2 would be the outer radius in this case. Okay, let's write like this. And this would be again 0, but this would be outer radius. And we need to specify stroke to make the line visible. Okay, yeah, now it's visible, and we need, so basically actually we draw 12 lines here now, and we need to move those lines, we need to rotate those lines, and for the rotation we can just rotate this parent G element, and we can write like this: attribute transform rotate. Yeah, we can use function to rotate it. First let's write like this: rotate, return rotate, and yeah, let's do 30. Yeah, okay, and we want to start, yeah, basically we can calculate each angle, and each angle would be, each line angle would be basically 360 divided by man's length, right? And multiplied by E. Yeah, E is index. So for the August, this value would be, I don't know, probably 12. Okay, no, it would be 0 because we are multiplying it to 0. This starts from 0. And for the September it would be 30, I think, because this divided to 12 and multiplied to 1, yeah, it would be 30. Okay, and we can just use this each angle variable inside this string. Yeah, now we can see we have those lines rotated, but actually I was wrong. Instead of 0 we need to specify, I mean for the x1 we need to specify inner radius and not the 0. Okay, it's interesting. Okay, I need to think about it. 1 minute. Okay, so x would be 0, but y would be inner radius. But we got nice result. Okay. Okay, and we could do the same for this as we did for the circle, and we can specify opacity as 0.1. And 0.1. Yeah, nice. Okay, we already have vertical axes. Now we just need to create texts, right? And we can just copy this code, and we can just append text, and this text will be again there. Yeah, and because in this case this data is actually months, we got these months names, and so we also need to move those texts, so we could just specify x attribute. It should be inner radius. Yeah, nice. And probably we need to subtract a little, but this is too much. This looks nice. Probably it would be better. This looks nice. Okay, and and instead of this we can use transform translate, and again we can use function and write return translate, and x would be and we could specify our x here, and we get the same result. But now, as you can see, in some cases we can't actually, I mean, it's backwards, right? It's top down, and we need to rotate this. But first, one thing I want to mention is that, as you can see, August starts from here, but our data actually starts from here. So we need to rotate those we need to rotate those G elements so that they start from here, and for that we can just write -90 here, and now it starts from August starts from the top, which is correct. Okay, so next part is, as I mentioned, in some cases we want to rotate months to be top down, so it could be visible, it could easily be readable, and for that we can just create, we can just rotate it here. Okay, let's define rotation value here, and let it be equal to 0, and we can receive index number in the second argument. And so now we just want to check if this index is more than 6 and less than 12. Let's rotate it. Okay, so we can check if E is more than 6 and if E is less than 12. We can just write rotation equals 160 or 80. Okay, nice. You can see now they are rotated, but they are too close to center, and for them we could just we could just adjust those x values for those months, and for this we can just specify x to be let, and in that case x equals inner radius, for example. I don't know if this will work. I think it works well. We can just subtract 20, probably 10. It's better now. As you can see, I can read all of the months kind of easily, and we also have vertical axes, and probably the only thing we want to add is this label at the top, and for that we can just write svg append text, and its text we want to be Kudauri temp. So this chart shows temperature in Kudauri. Kudauri is winter resort in Georgia, and as you can see, during summer it's quite temperature is, I mean, it's not, I don't know, it depends, I guess, but it's kind of average. But in winter you can see it's below 0, and usually this is the winter season, when we can snowboard or ski. Okay, I can just write Kudauri temp. Okay, and I can just move those texts using transform. Okay, and I want it to be translated to width divided to 2 here, and I want it to be a bit below, so let's do like this. No, this is like this, probably again this, and let's move it a bit left. Okay, I should write it here, probably 60. Yeah, and we need to specify that it's in Celsius. Yeah, nice. Okay, yeah, we did it. This is how it looks. Okay, and yeah, I guess this is it. We were able to reproduce this graph, and yeah, we learned about arcs, we learned about SVG essentials, we learned about color scales and value scales, and yeah, most importantly, we learned about what the process looks like, what is the process when building these visualizations. Yeah, I think this is it. Thank you very much, and I hope this was useful, and I will link this code under YouTube description, so you can take a look. Basically, I think I will just copy and I will just link this code inside description. I hope this will work I think it will work. Okay, thank you very much. Take care and goodbye.